The Mechanics of Materials Group at the Eindhoven University of Technology has set up a unique laboratory for integrating mechanical characterization with microscopic visualization. This multi-scale lab is equipped with various small-scale mechanical test devices covering a force range from kilonewtons to nanonewtons. This includes unique mechanical test instruments that have been developed for dedicated research projects. Integration with various microscopic techniques enables in-situ observation from meters to nanometers. A range of in-situ mechanical tests can be performed in the MultiScaleLab using instruments such as small-scale microtensile and microcompression devices fitting all microscopes, a miniature mixed-mode bending setup to test material interfaces, a thin-film bulge tester and a unique Marciniak punch setup for use inside a scanning electron microscope, a miniature free bending stage for moment-controlled loading for foils and thin films, instrumented indentation and scratch testing at micro and nano scale for local mechanical characterization, a highly accurate uniaxial tensile tester for on-chip structures or individual phases in bulk materials, harmonics, which is a method for mapping material properties at the nanometer scale, a piezo-driven triaxial test device for dynamic loading in tension and shear. The MultiScaleLab exploits a range of microscopic visualization techniques, environmental scanning electron microscopy equipped for orientation imaging and elemental mapping, optical profilometry bases on confocal microscopy, interferometry and digital holography, atomic force microscopy and scanning tunneling microscopy for the smallest scales, optical microscopy with a range of imaging techniques and contrast modes, X-ray computed tomography for non-destructive 3D imaging with sub-micron voxel resolution, digital image correlation with commercial codes and a range of dedicated codes developed in research. The research in the MultiScaleLab covers various application areas, ranging from manufacturing to high-tech systems. This research is conducted in cooperation with other scientific institutes and our industrial partners, including many key high-tech companies active in the Netherlands. Please regard some case studies. Surface roughening during forming of coated metal sheets directly affects the adhesion of the protective layer. Metal stretching experiments were performed under optical profilometry, and the surface height profiles were correlated with our advanced digital image correlation algorithms. This results in a three-dimensional displacement field. The micromechanics of flexible and stretchable electronics is studied in detail in the MultiScaleLab. For instance, the copper-rubber interfaces in stretchable electronics show a remarkably high fracture toughness. This was shown to be caused by the formation of microscopic fibrils in the delamination front, as shown in the movie. Fibrous networks form another challenge case, since small loads or changes in temperature and humidity may induce complicated micromechanical deformations leading to failure. For example, the ultimate load of an electronic textile with active components is governed by the component interfaces or the failure of the conductive yarns. The latter is studied here for a textile loaded under tension. High-strength materials are used in many industrial applications, for instance, to make cars stronger and lighter. Failure of these materials is determined by plasticity and damage initiation at the micron scale. These micromechanisms can be quantified by digital image correlation of images taken by scanning electron microscopy. In general, the macroscopic material behavior is determined by microscopic deformation phenomena that occur at the scale of the microstructure. Therefore, to predict the macroscopic properties, micromechanical tests are performed under in-situ microscopic observation. The example shows a tensile test on a single ferrite crystal isolated from bulk steel. The MultiScaleLab is a unique lab, bridging the gap between materials science and mechanical testing, between modelling and experimentation across the scales, and between quantitative testing and in situ microscopic observation. We gratefully acknowledge the financial support of all our sponsors, which made it possible to establish this excellent research facility.